So in this way, um, PVM or Python interpreter manages asynchronous programs or coroutines efficiently than the sequential programs. I have to explain one more concept here, and um, that is about this particular area. So, as you know, this is the processor. So this kitchen area represents the processor, and each of this kitchen, right? They have three different kitchen. I am mm, highlighting three different kitchen here. So each of these kitchen represent a core of the processor. So this is a three-core processor, and they have uh, three cores available in this processor. So as I shown here, as I uh, draw here, only one kitchen will be active. The other kitchens are inactive. So this is to represent the Python mode of execution. So um, in Python asynchronous mode of execution, the Python asynchronous programs are running using single process and single thread. So a single process and a single thread process in Python can only utilize one kitchen, can only utilize one kitchen. So Python implementing asynchronous programming using single process and single thread, and a single process and a single thread programs in Python can only utilize one kitchen at a time. So uh, this is not a limitation of Python. In most of the other programming languages also, a single process and a single threaded application can only utilize one core of the process. So other cores, other CPU cores will not be utilized in Python asynchronous mode of execution. So as you know, in Python asynchronous mode of execution, multiple tasks are handled simultaneously. So multiple coroutine functions are running at same time, even though it is not handled uh, by different process or different thread. So multiple coroutines or multiple asynchronous functions are handled using single process and a single thread. So let me explain a little bit more here. So when you are running a program, something like you will type something like Python your main.py. When you are running a function like this, and in operating system level, it is starting a process. So this will be a PVM process. As you know, this will be a PVM process, um, and there will be having this PVM process will be having a loop. We can call it as main loop. So this main loop you can consider as the thread. So these operations are in happening in OS level, but how the instruction have to be handled, how memory have to be handled, those things are handled by this PVM process only. So when you are calling a function, when you are running a Python program, um, it is starting a process in operating system level. It will be a PVM process, Python which interpreter level process, and this process will be having uh, inside it, it will be having a loop. We can call it as main loop. So this type of loops that fetch um, the instructions one by one. So there will be having an instruction queue that load all instructions um, that have to be run. So there will be having an instructions queue, or you can call it as task queue. So this main loop um, fetch the instruction, and after that it execute the instruction. So it will do different step to execute those instruction, and again it will fetch the next instruction from the task queue, then it execute it, then again it is fetching the instruction from the um, task queue or instruction queue. So that's why it is called a loop. So this type of loops are called as threads. This type of loops that fetch the instruction one by one and execute is actually called as the thread. So in normal Python execution mode, um, it will be having one process, and inside that process one thread will be there. Thread means a loop that fetch the instruction and execute, again it fetch the next instruction and again execute it, and again fetch next instruction and execute it. So these type of they have many other steps to manage the memory, to load convert the instructions. So they have many other steps, as you know, to be performed. So all these um, steps are called inside this main loop. So that is the concept behind the main loop or thread, um, and uh, the single process, single thread applications can only utilize one core of a processor at a time. So that's why I am showing here in this area. That's why I am showing only one kitchen as active, and I am graying out the other kitchens. So I will explain these concepts in detail in the coming slides. So I'm stopping this slide here, and I'm moving to the next slides. So suppose you are writing a program main.py. So all of your program, your functions, everything will be written inside this main.py. And if you want to run this main.py program, you are giving a command like python main.py. So Python here is the executable which is responsible to start PVM and do the initial setup for PVM and run your program. And main.py is the command line argument to the Python. So main.py or the path to your Python program will be considered as a command line argument to this Python executable. So when you are running your program main.py using this command, right? Python main.py, what operating system will do? Operating system will create a new process to run main.py. So you are writing a program, and after that you are running it using Python main.py. So Python is an executable which will start the PVM, Python virtual machine, and main.py is the program you wrote. So to run this program, you have to give something like Python main.py. So when you are running this application, this executable, Python executable with this command line argument, OS, operating system, OS, operating system, create a new process create a new process to run main.py. So this process will be a PVM process, Python virtual machine, right, or Python interpreter. So when you are calling the Python main.py, operating system will start a new process to run main.py. So that process will be PVM process, PVM or interpreter process, right? So this process. So we were um, discussing about this process when a program is started. We told that one process will be it will be it will be executed using single process and single thread normally. Otherwise, we have to uh, write specific code to start a new process and new thread inside our program. So normally, when you are running a Python program, it will create a single process and it will create a thread. So what is thread? Thread is nothing but, for example, you are writing this program, right? So when the PVM started, so what a Python virtual machine will do, it will first compile your main.py program and will create a bytecode. And using that bytecode, the interpreter will be starting. So they have two-step process. In the first step, um, the PVM Python virtual machine compile your main.py. So that is the first step to check the syntax errors and all. And the bytecode will be generated also. And using this bytecode, the interpreter will be starting the execution. So we can imagine something like initially the PVM will create a task queue or instruction queue. So we can draw an instruction queue. So here, so suppose this is the insertion queue. So I'm drawing an insertion queue here. Can call it as uh, IQ or insertion queue. So what this process is doing, what the PVM or interpreter process is doing. So interpreter is actually running a loop, while loop. You can imagine this may not be the right uh, uh, implementation, but uh, the method is same. This is how it is working. So we can imagine as the interpreter process is entering into a loop. So while true and uh, it is instruction equal to pop IQ. So the queue will be popped, and after that the next step is execute. So this loop, right? So this loop is called the main loop or main thread. So this is the thread actually. This process is created in operating system level. So I told that OS create a new process. So operating system can only create a process. Similarly, the thread is also managed by the operating system. So the interpreter can instruct how the instructions have to be executed, when the instruction should be popped. Those things interpreter can instruct. But the actual execution of this loop and actual execution of the instructions have to be carried out by operating system. Only operating system can handle it. Otherwise If individual applications are directly trying to execute, it will be something like chaos. um, Memory management or processor CPU management, and IO management. Um, the each individual applications cannot handle other applications, um, right? So there should have a central person to manage the entire thing. So that is why OS is very important. Operating system is that central manager of the computer. So operating system start the process, and operating system entering into a loop, and that loop extract the instruction queue, right? They have a task queue, or we can call it as instruction queue or task queue. So operating system is actually popping the task queue or instruction queue that is actually created by Python virtual machine or interpreter. So it is popping this instruction, and that instruction will be executed. So, and once it is completed, the execution is complete, it will move into the next instruction. So once it is this one, right? Once the first instruction is completed, it will go to the next. It will pop the next one, then next one, next one. So this is a loop until it is reaching the end. It will be executed. So this loop is called the thread. So in normal Python, you can create multiple threads. So when you are telling you are creating a thread, you are actually creating one another loop that are going to be handled simultaneously. So you are going to create a new thread parallelly. You are going to when you are creating a new thread, you are going to create a new uh, loop that can fetch instruction from one another instruction queue, and that instruction queue may be defined by a function. So I'm not it is out of the scope, so I'm not explaining that part here. So I will be doing a separate video for thread, how threads are handled and all. So here I am, my focus is um, uh, this main loop, and what is main loop, and what is a process. So when you are writing a program main.py, um, you are writing your functions and instructions inside it, and you are running it using Python main.py. So operating system create a new process to run this main.py. So that process will be a PVM, Python virtual machine process. That is actually the Python executable, right? So based on this Python executable, you will be starting that, means operating system will be starting a new process. So this process will uh, first, right, or PVM, Python virtual machine, is creating an instruction queue or task queue. You can call it as task queue or instruction queue, and the PVM is entering to a loop. We can call it as main loop. So this loop is actually popping instruction one by one from this queue, task queue, and executing it, and after that fetching the next instruction. So this loop, right, this particular loop is called a thread, right? So um, um, thread is nothing but a loop that can fetch instruction by instruction and execute it. So when you are creating one another thread, um, you are actually creating a new loop, and that new loop fetch instruction from one another instruction queue. So who is handling it? Operating system is handling it. So threads are handled by operating system directly. The main loop, and if you are creating one another thread inside your program, um, internally you are calling a system level function to create a new thread. So operating system will create a new thread. So new thread means it is a new loop, something like this main event loop. You are parallelly creating one another loop that fetch instruction from one another queue, instruction queue, and it will be handled parallelly. But they have many other topics, something like global interpreter, lock, and all. So that part lock, the Python is putting some lock in between the multiple threads, so only one thread can run at a time to avoid the confusions and all. That we will see in one another video when I am explaining about the thread, parallel programming using thread. I will do a one another um, chapter on this topic. So let's stop this one. It is getting extended too much. So let's stop this topic right now, and let's move into the next slide. In this slide, I am going to summarize the concept we were discussing previously. So this slide explains the working of subroutines. So subroutines are also called as functions or methods. So in normal way of execution, the in the normal sequential way of execution, it is calling the subroutines or methods. So generic functions, generic operations we are putting inside a method, function, or a subroutine, and we can call it multiple times from multiple locations. So this is the concept of subroutine. If they have some set of repeated operations, we can put it inside a subroutine, and we can call that subroutine from any other locations. So the other concept is coroutines. Coroutine is also the same concept of subroutine, but coroutines, um, multiple coroutines can run at the same time. So in subroutine, you are calling a function here, and the control is going to that called function, and the instructions or operations inside that functions or subroutine will be called one by one, and the control is coming back to the main uh, main loop or main string, and again the other operations are executed, and the and if they have other subroutine call or other uh, function call, it will be called. um, then control will move to that function, and the instructions or operations inside that function will get called, and after that, after executing all instruction, control will come back to the uh, next line of calling function, and the flow will continue. So here also it is showing main is starting going control to the subroutine A, then going control to the subroutine B, and so on. So this is the normal way of execution of subroutines. So in this new slide, I am explaining the next concept, that is coroutine. So previously I was explaining subroutine. So coroutine is actually subroutine itself. So multiple subroutines can work together simultaneously, parallelly. So that is the concept of coroutine or asynchronous programming. So asynchronous programming in Python is achieved using coroutine. Coroutine are subroutine only, but those subroutines can work together. So the subroutines that can work together can be called as coroutine. Cooperatively, they can work together. So it is based on concurrency. So concurrently, multiple coroutines can work, and suspend resume. So one coroutine can start the working and pass the control to the one another coroutine or to the main loop. And after some time, it can again resume its work. So this is the architecture of coroutine. So one coroutine can start its work, and after that, um, after some time, it can wait or it can suspend its execution and pass the control to other coroutines. So other coroutines can continue from that location, and after some time, the first coroutine can resume its work. So uh, together, it have to be written in that way. So altogether, it can work. Multiple coroutines can work cooperatively. So don't focus on this picture so much, but just let me explain it. So it can initialize two coroutines simultaneously, and the coroutine can wait um, in some location of the code. It can wait, it can suspend its execution and pass the control to the first coroutine or first main loop. Then main loop can continue its execution, and when required, you can again go back. You can instruct the Python interpreter through your program to pass the control to the previous coroutine. So it will resume from where you suspended last time. So the coroutine is actually working based on starting a coroutine and waiting for some data, waiting for something, then pass the control to some previous coroutines or to the main loop, and again whenever required, come back and resume the work. So together they can cooperatively work. So this concept we will see how Python is achieving it. That part we will see in the coming slides.